Have you ever gazed up at the night sky, wondered about the moon, and thought, why does Earth have just one moon while other planets have so many? It's a fascinating question that opens up a whole universe of exploration about our solar system and beyond. Today, we're diving into the mysteries of why some planets are blessed with numerous moons, while others are left moonless. Buckle up, because this journey through space is going to be out of this world. First, let's clarify what a moon is. In astronomical terms, a moon is a natural satellite. Unlike artificial satellites launched by humans, natural satellites are formed through natural processes in space. They orbit planets, asteroids, or even other moons. The variety in the number of moons a planet has can be staggering. For instance, while Earth has just one, Saturn boasts a spectacular 146 moons. Why is there such a dramatic difference? The reasons lie in the formation and evolution of our solar system, and understanding these reasons takes us on a journey through the cosmos and the forces that shape it. The most straightforward explanation is gravity. Gravity is the force that attracts objects toward one another. The larger an object, the stronger its gravitational pull. Our Sun, being the most massive object in the solar system, exerts a dominant gravitational force, keeping planets in orbit around it. Similarly, planets exert gravitational forces on objects near them, including potential moons. However, for a planet to capture and retain a moon, the moon must be within a certain distance, known as the Hill sphere. The Hill sphere is essentially the region around a planet where its gravity dominates over the gravity of the Sun. The size of a planet's Hill sphere depends on both the planet's mass and its distance from the Sun. Let's consider Earth and its moon. Earth's Hill sphere is large enough to keep the moon in orbit around it, but if the moon were farther away, the Sun's gravitational pull would likely capture it, and it would no longer orbit Earth. This delicate balance is why some planets, especially those closer to the Sun, may have fewer or no moons. Mercury, the closest planet to the Sun, has a very small Hill sphere due to its proximity to the Sun and its relatively small mass. Any potential moons would be more strongly attracted to the Sun and thus unable to remain in orbit around Mercury. Similarly, Venus, although larger than Mercury, is also quite close to the Sun and has no moons. Mars, our neighboring planet, has two small moons, Phobos and Deimos. These moons are believed to be captured asteroids from the nearby asteroid belt, demonstrating how proximity to other celestial bodies can influence a planet's moons. Moving further out, we find the gas giants, Jupiter, Saturn, Uranus, and Neptune. These massive planets have much larger Hill spheres, allowing them to capture and retain many moons. Jupiter, the largest planet in our solar system, has 95 known moons, including the 4 large Galilean moons, Io, Europa, Ganymede, and Callisto. These moons are fascinating worlds in their own right, with features like volcanic activity and subsurface oceans. Saturn, with its 146 moons, is another giant with an extensive family of moons, ranging from tiny moonlets to the massive Titan, which is larger than the planet Mercury. Titan is particularly intriguing with its thick atmosphere and surface lakes of liquid methane and ethane. Uranus and Neptune also have numerous moons, though not as many as Jupiter and Saturn. These ice giants are farther from the Sun, which means their Hill spheres are less influenced by the Sun's gravity, allowing them to maintain their moons more easily. Another factor influencing the number of moons a planet has is the history of collisions and interactions in the early solar system. During the formation of the solar system, collisions between protoplanets and other large bodies were common. These collisions could knock moons out of orbit, or even create new moons from the debris. For example, Earth's moon is believed to have formed from the debris of a massive collision between the early Earth and a Mars-sized body. This giant impact hypothesis explains why the moon is composed of materials similar to those found on Earth. In contrast, the moons of the gas giants may have formed in a more orderly manner. As these planets formed, they accumulated gas and dust in a disk around them. Moons could form from this material in a process similar to the formation of the planets around the Sun. This is why many of the moons of Jupiter and Saturn orbit in the same direction and plane as the planet's rotation. But not all moons form this way. Some are captured objects, like Mars's Phobos and Deimos. Others, like Neptune's moon Triton, are thought to be captured Kuiper Belt objects, which are icy bodies that orbit beyond Neptune. The variety of moons in our solar system is a testament to the complex and dynamic history of planetary formation. From the volcanic activity on Io to the subsurface ocean on Europa, each moon tells a unique story about the conditions and processes that shaped it. So, why does Earth have only one moon while other planets have so many? It's a combination of factors: Earth's location in the solar system, its mass, its gravitational influence, and its history of collisions. Each planet's moon story is unique, shaped by the intricate dance of gravity and the chaotic events of the early solar system. As we continue to explore our solar system with missions like NASA's Artemis program, which aims to return humans to the moon, and the upcoming Europa Clipper mission to explore Jupiter's moon Europa, we will undoubtedly learn more about these fascinating celestial bodies and the forces that govern them. Our journey through the universe is just beginning. Every new discovery brings more questions, sparking curiosity and inspiring us to keep looking up and wondering. What other mysteries await us out there? Only time and exploration will tell, but let's not stop there. To truly grasp why our moon is so special, we need to delve into its unique formation story. The prevailing theory, known as the giant impact hypothesis, suggests that around 4.5 billion years ago, a Mars-sized body named Theia collided with the early Earth. This catastrophic event ejected a significant amount of debris into space, which eventually coalesced to form our moon. This theory is supported by the composition of moon rocks brought back by the Apollo missions, which closely resemble Earth's crust. The moon's influence on Earth extends far beyond its presence in our night sky. It plays a crucial role in stabilizing Earth's axial tilt, which in turn regulates our climate and seasons. Without the moon, Earth's tilt could vary wildly, leading to extreme and unpredictable weather patterns. The moon's gravitational pull also creates ocean tides, which have been essential for the development of life on Earth. Tides mix ocean waters, distributing nutrients and supporting marine ecosystems. Our moon is a testament to the interconnectedness of cosmic events and their impact on life. It's not just a passive satellite, it's an active participant in the story of Earth. This relationship highlights the importance of moons in understanding planetary systems as a whole. Now, let's explore the other side of the spectrum: planets with many moons. Jupiter, with its 95 moons, presents a fascinating case study. Its 4 largest moons, known as the Galilean moons, were discovered by Galileo Galilei in 1610. Each of these moons, Io, Europa, Ganymede, and Callisto, has unique characteristics that make them intriguing objects of study. Io is the most volcanically active body in the solar system, with hundreds of volcanoes spewing sulfur and other materials. Europa, with its icy surface, is believed to have a subsurface ocean that could potentially harbor life. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury, and has its own magnetic field. Callisto, heavily cratered and ancient, offers a glimpse into the early history of the solar system. These moons are not just satellites, they are worlds in their own right, each with its own story to tell. The study of these moons provides insights into the processes that shape planetary bodies and the potential for life beyond Earth. Saturn's moon Titan is another fascinating world. With a thick atmosphere rich in nitrogen and methane, Titan has weather systems that include methane rain and lakes. The Cassini-Huygens mission revealed that Titan's surface is dotted with rivers, lakes, and seas of liquid methane and ethane. This makes Titan the only other body in the solar system known to have stable liquid on its surface. Exploring Titan is like stepping into an alien world where the chemistry and climate are entirely different from those on Earth. The presence of complex organic molecules raises intriguing questions about the potential for life and the processes that led to the formation of these molecules. As we look further into the outer solar system, Neptune's moon Triton stands out. Triton is unique because it orbits Neptune in the opposite direction to the planet's rotation, a retrograde orbit. This suggests that Triton was likely captured by Neptune's gravity rather than forming alongside it. Triton is also geologically active, with geysers of nitrogen gas erupting from its surface. These diverse and dynamic moons remind us that our solar system is full of surprises. Each moon, with its distinct characteristics and history, adds a piece to the puzzle of how planetary systems form and evolve. In our quest to understand the universe, we must also consider exoplanets, planets that orbit stars outside our solar system. With the discovery of thousands of exoplanets, scientists are now searching for exomoons. These moons could be crucial in determining the habitability of exoplanets, as they may influence the planet's climate and geological activity. The study of moons, both in our solar system and beyond, is a rapidly evolving field. As technology advances, new missions and telescopes will allow us to explore these distant worlds in greater detail. The James Webb Space Telescope, for instance, will provide unprecedented views of exoplanets and their potential moons, shedding light on the processes that govern their formation and evolution. So, the next time you look up at the moon, remember that it's not just a beautiful object in the sky. It's a key to understanding our place in the universe, its formation, its influence on Earth, and its comparison to the moons of other planets offer invaluable insights into the nature of our solar system and the broader cosmos. Our journey through the universe is far from over. Every new discovery brings more questions, sparking curiosity and inspiring us to keep exploring. What other mysteries await us out there? How many more moons are waiting to be discovered, each with its own story to tell? As we continue to push the boundaries of exploration, one thing is certain: the study of moons will remain a central theme in our quest to understand the universe. Whether it's our familiar moon, the distant moons of the gas giants, or the yet-to-be-discovered exomoons, each one holds a piece of the cosmic puzzle. So keep looking up, stay curious, and join us on this incredible journey through the stars.